In this video, we are going to discuss matrices, SAQs, page number 89, example 1. Very important, many times repeated in the examination. Show that determinant of 1a square, 1b square, 1c square, which is equal to a minus b into b minus c into c minus e. See how to prove that. Taking the given determinant here, given that determinant of 1a square, 1b square, 1c square. See here, if you observe that the first column elements are equal to 1, so now you can apply all the elements are equal to 1 only in the first column elements. So you can apply the row transformations. This is R1 here, and this is R2, and this is R3. Now what I am doing is here, R1 writing in the place of R1, and R1 to R1 minus R2. Now first I am doing here, so R1 to R1 minus R2. I am subtracting R2 from R1, writing in the place of R1. So here A minus B, this is A square minus B square. And similarly here R2 to R2 minus R3. So that means, so writing in the place of R2, subtracting R3 from R2. That means 1 minus 1. Here B minus C. So this is B square minus C square. And last row R3 row writing as it is. So now what happens here? So which is equal to here we get, so which is equal to, see 1 minus 1 we know that 0, determinant of this is 0, and A minus B writing as it is, and A square minus B square. See, we know that the formula for A square minus B square is equal to A minus B into A plus B. A minus B into A plus B. So similarly 1 minus 1 is 0 and B minus C here. So now again B square minus C square formula is also, so like B minus C into B plus C we can write. See, we have here the last row writing as it is 1C square. See here, if you observe that we have the formula for A square minus B square, so which is equal to A minus B into A plus B, which is equal to A minus B into A plus B. Similarly, here also applied that B square minus C square also by using the same formula. So we can write it as B minus C into B plus C. So that's why I applied here for B square minus C square is also B minus C into B plus. Now what I am doing, if you observe that this is now R1 row is this is, and R2 is this is, and R3 is this is. What I am doing is, so taking A minus B and B minus C common, taking common from R2 or from R1. From R1 we have the A minus B. So that's why from R1 and R2. From R1 and R2. See, in the R2 we have A minus B is common. In the R1 we have A minus B is common. In the R2 we have B minus C is common. So that's why here, so in the R1 if you take A minus B common, see what we get here, 0. Here after taking the A minus B common 1, and A minus B common here 1 into A plus B, that is A plus B only we get. And again here, after taking the B minus C common from the R2, we get here 0, and this is 1. Here 1 into B plus C, that is B plus C we get. And last row I am not changing anything, writing the last row is as it is on. See, observe here, once after converting the, so in the column elements, first column elements, any two ones as zeros, now you can expand the determinant. Now expanding determinant, expanding determinant, expanding determinant along so R1, along R1, see here. Now if you expand the determinant along R1, see here. So if you expand the determinant along C1, this is not R1, C1. See here, this is first column, no? So that's why expanding the determinant along C1, this is C1, this is R1, so this is R2, this is R3. Now expanding determinant along C1. So C1 deleting and R3 is also deleting. So we get here A minus B into B minus C into here last element along expanding the determinant along C1 only. No, last element is what? 1. So 1 presenting row and column if you delete, we get the determinant of 1 here A plus B and 1 B plus C. See, along the C1 if you expand the determinant, we get here 1 into the 2 by 2 matrix is 1 A plus B, 1 B plus C. So now which is equal to A minus B into B minus C. Now if you find the determinant of this 2 by 2 matrix, we get here B plus C, immediately minus. So that's why multiply with minus. So then minus A minus B, this is A. So finally we get BB gets cancelled. So we get here A minus B into B minus C into C minus C. So that's why this is only the RHS. Suppose if you take the given that LHS determinant of 1A square, 1B, B square, 1C, C square, we get RHS is A minus B into B minus C into C minus A. This is the RHS. So therefore LHS is equal to RHS. So like this we can prove this is very important problem.